Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. Today's topic is about joins. This is one of the most important or interesting topic in SQL. Now, let's look into what are we going to discuss. In this topic, I will be discussing about types of joins with relation to only one condition and two datasets or two tables. And in here, I'm going to discuss inner, left, right, full and cross join. And also we will look into special conditions of self join and join with the index. Then we will look into how do we do joins when we have more than one condition and when we have more than two tables. Then we will look into cardinality in joins, that is one to one, one to many and many to many joins, followed by couple of miscellaneous topics, that is what happens when we do joins with aggregation, and then what happens when we do select star from two joining tables. Now let us first start with types of joins. Now let us first discuss what is a join. This is just simple explanation and we are going into looking into examples and then we will try to understand joins. Join is nothing more than combining two or more data sets horizontally on the basis of common variable or variables. The general idea to do a join is to bring different variables from different data sets into one query or table. But you can do a lot more than what I'm saying in here. Now let's first talk about simple inner join. And in here, when we are talking about inner join, we will try to understand this through an example. Here we have two data sets, dataset 1 and dataset 2, and we have variables ID and age in dataset 1 and ID and salary in dataset 2. And in here, what we are doing is we are doing a inner join. And let's look into the code below. And let's start from the from clause itself. Here we have from 1 inner join 2. So whenever we want to do an inner join, first we need to say from dataset 1, whatever we want to put in here, and dataset 2. And then we are going to say on 1.id equal to 2.id. What is meant by 1.id? When we say 1.id means this id variable is from dataset 1. When we say 2.id, it is from dataset 2. This is especially important whenever we have the variable names which are same in both the dataset. If we are not going to mention 1.id and 2.id, we are going to get an error. Now let's look into our select clause. In the select clause also, I have mentioned the variables as 1.id, 1.age and 2.salary. And in here, I need to definitely mention 1.id because if I'm not going to do that, it is going to give me an error. But 1.age and 2.salary are not important. But it is an important practice to have things like 1.id, 1.age and 2.salary so that whoever is looking into the code, he can directly understand that these particular variables are coming from this data set. And even if we don't mention 1.age, 2.salary, it's not going to give any error. It's just a best practice to do so. Now let us try to understand results in here. And whenever we do an inner join, results are based on matching of the joining column. That is, whenever the ID in this data set matches to ID in this data set, we are going to get the results in here. Here ID1 is there in both the tables, so we have results related to ID1, and ID2 also is there in both the data set, so we see the result as shown in here. ID3 and ID4 are not present in both the tables, so you don't see that in your result. That is all about simple inner join. Now let us see how can we make this code little bit more simpler. Generally, what we do is we write from 1 as A, or we can just say from 1 and A. And this is known as aliasing. Instead of using 1, now you can use a.id. Same is the case of 2, wherein I have mentioned B and then I have mentioned b.id. So instead of writing full name in our on condition, we can do an alias. An alias, we can write 1 as A, but 1 and space A also works. In simple inner join, your results are based on matching of joining column. Now let us quickly go ahead and look into a left join. A left join is also very similar to inner join with some additional results. Let's look into the code first, and then we will go ahead and discuss the results. We are doing everything same in here, what we have previously done in the inner join, but we are going to mention left join. What is left here means? What does the join name here means? The first table, whenever you have, it is always known as left table, and the second table is your right table. So whenever we have said left join and we have used from 1, this particular table becomes left table. Now the code is almost similar what we have discussed. Let's look into the results, and also let's discuss briefly about left join. Left join gives the results based on matching of the joining column, like what we have seen in inner join, and also it brings non-matching data from the first or the left table. What does that mean? Is that when ID1 is having a match in both the tables, we see the results in here. When ID2 has a match in both the data sets, we see a result in here. And ID3 does not have a match in dataset 2, but because this is a left table, the information from the left table will also come into the result, and we will have missing information from right table variables. Here if you can see, here right table variable is b.salary and it will be missing. To sum it up, whenever we do a left join, we have all the information from the left table. That is what all the variables we kept in our select will have all the values, and matching values only from the right table, and it will also have missing value from right table whenever it does not have match. Now let us talk about right join. Right join is pretty similar to a left join. Only difference is now the important table is our right table or our second table. Here it is 2. And you will have all the information from right table, and whenever there is no match, that is in the case of 4, there is no match, so we will have the information related to 4 ID also, but you will not have any information related to 4 in here. So For right join, we will have all the information from right table, only matching information from left table. That is when ID is 1 and 2. And I want to mention a very important point here. If you see, I have written b.id, and if we go back here, it is a.id. Whatever is our right table, we need to pick id from that variable. If we are not going to do that, and if we are going to do a.id, it is going to be missing here. This is one important point we need to remember. Other than that, everything is same. Now let's go ahead and discuss full join. Full join, with the name itself, it is again very clear that we want information from both the tables. That is, whenever they have a match, we want that. Whenever they do not have a match, we want those information also. And here the keyword, obviously we have changed from left and right to full join. If you see here, I am interested in id variable for this data set, that is data 1, and also for this data set. Because it's a full join, we want all the information from all the tables. That means whenever we have our joining variable, I want this 1, 2, 3 also to come into my data set, and also I want this information also to come into my data set. That is 1, 2, 4. And couple of important points. Here, for this particular ID, there is no match. So we have those values 3 and 45 and missing values for corresponding dataset 2. And the same is the case with the 4. And here I have a.id and b.id, unlike what we have seen in right and left join, because we are interested in both the IDs. Again, to sum it up, we have information from both the data sets. Whenever we do not have any information related to that particular ID in another data set, that will go missing. Now let us look closely into the results. Here we have two variables, id with the same name. And if you see here, again another important point is the information is redundant, means I have value 1 and 1 again, 2 and 2 again. 3 and 4 are fine because they are there, because they are not duplicated. Now, how can we make this look better? It is super simple. All we need to do is we need to apply coalesce function on a.id comma b.id, and then we need to say as id. So what coalesce function does is it picks up first non-missing value. Say here we have id 1 and 1, it picks up first non-missing value 1, and that is what we want. Here it picks up 2, and in this case this is the first non-missing value, it picks up 3, and in this case this is the first non-missing value, it picks up that one, and it makes it look much nicer. Whenever you do a full join, please remember to pick the main variables from both the data sets, and in this case I am taking that as id, and then I am using coalesce on that. Sometimes you may have more variables in which you are interested. Remember, if you want the information from both the tables, you need to do a coalesce and do something like this, which looks much elegant. One another important point to remember is whenever we do a select, we get a result like this, but we can't create table like this because we can't have two variable names in one data set. So it does not work in create table statement. Regarding create table statement, we will be looking into our future videos. Now that we have looked into all kinds of joins, now let's go into a something unique and different join, that is cross join. This kind of join we rarely use, and then what we are going to do here really is we are going to join this dataset with this dataset, but this join is not based on any variable. What does that mean? I want, for example, in this dataset, this Toyota 10,000 to combine with all of these values, Honda with all of these values, BMW with all of these values. So how can I do that? I can simply do that by using cross join. Now I want you to focus here. I do not have anything like on, means I'm not joining on any variable. All I'm doing is I'm using cross join. What this does is this just combines this value with all other values in the data set, and it is shown as here. I do not want to delve too much into cross join, but I want you to be also to be careful whenever you are doing a cross join. If you see here, I have 3 records in here and 3 records in here. When we do a cross join, we get 9 records here. So what happens if we have 1,000 records here and 5,000 records here? You can imagine you are going into a big number when you have little bit more higher numbers and you are doing a cross join. So always be careful of doing a cross join. Now we have looked into all the categories of joins, but I would like to go a little bit more deeper, and by using these joins we can do something special. One of those is self join, and the second one is join on index function. Let us first look into self join. To understand self join, we also need to understand couple of things. Whenever we are trying to do a self join, the information we want is all there in one table, but not in the way we want. So unlike where we do joins with multiple tables, the information is spread over multiple tables. That is, you want variables from this particular data set and that particular data set, or you want to compare 2 data sets. But in the case of self join, all the information is embedded in one data set. The only difference, as I said earlier, it's not the way we wanted it. So to understand this point, let's look into a data set. Here for this data set, what I have done is I have taken this data set from internet. Here I have a create table statement followed by insert into statement. Here we are creating a table which has employee ID, and it has first name of employee ID and last name of employee ID, and we also have manager ID. Manager ID is nothing different. Actually, for this employee ID, this particular one is manager ID. What does that mean? To understand this, let's also look into the data so that it becomes more clearer, and especially let's look into first and second insert statements so that we can understand it more better. Here we have one as employee ID, first name as Windy and second name as Hayes, and then we have no manager ID for this particular person. And in the case of second insert, our employee ID is 2 and her name is Eva Christensen, and her manager ID is 1. So for example, now instead of 1, I want to see the name of that particular manager. Who is the manager? If you look closely, one is here too, but it is known as employee ID. But when we use for manager, we call that as manager ID. So both are same, but one is used for finding employee, another is used for manager. So if I join this observation or this row with this row on manager ID equal to employee ID, then what I will get is I can pull this information of Windy Hayes. That is, in my final observation, I will have to Eva Christensen and then Windy Hayes as manager ID. I know it is not fully clear. Now let's look this through code, and also I will show this you visually so that it is more clearer. On the top, I have visual representation. On the bottom, I have the code. Now first, let's look into the code as we have been looking all the way through. Here, let's look into our from. Here I have employee, that is our table name. And also after inner join, I have another employee, which means I'm using the same data set twice. So that is what is generally called as a self join. And also I want you to understand that we have aliased them differently, one as E and one as M. And then we are joining on E.manager ID equal to M.employee ID. And we can try to understand this better with the picture in here. In the picture here, I have mentioned table E and table M. As you know, these are aliases and the result in here. So what we are saying in here is whenever that E.manager ID equal to M.employee ID, I want that in the result. Now couple of points in here. I have color coded all of this to explain you that whenever the manager ID and employee ID matches, they have similar color. This is just a visual representation. And also in our select, what I'm saying is concatenate first name and last name of E table and make it as employee. That's what you can see in the result in here. And also we are concatenating first name and last name from M, and then that we are calling it as manager, and you can see in the results here. So remaining part of the results are self-explanatory. What I wanted to tell you here is instead of having two different tables, what we have done is we have used the same table twice. That's what is all about self join. And this inner join is no different than joining two different tables. Self join is just a special case and it is little different. And now let's look into join on index function. To understand the join on index function, we need to understand little bit about the data. Here I have data new and data new one, and here I have var1 and here I have call1. And then if you see here in var1, I have answer, question and joker as values. In call1, I have ans and joke. The idea is to find whether this particular string is present in this particular string. And to do that, we use index function. And I'm not going to go into details of index function, but we again can do the similar inner join, but now we are saying on index a.var1 because I have called this table new as a, and then b.call1 on the index function when it's greater than 0. And why I'm interested to show this join on index function? This is because of two reasons. One, I can do join just not on the exact equal to condition, but I can do on substrings and also on other variations. So whenever this index finds this particular string, we are doing our results, or we are getting our results as shown in here. And here I am just picking up the values from only the data set new. So we have answer 100 and joker 89 because this is where our values match. But whenever you are not joining on equal to condition, be always careful. Why? For example, if we have other rows which also had ANS in it, it will join with that. And also, you can also have a Cartesian product. More on what is Cartesian product in very few minutes. But be always careful while doing joins like this. Now let's also quickly look into different things. As till now I have been just joining with only one table. Now let us discuss about joining with more than one table and using additional variables on join. Here I have three data sets in which I have called as data 1, data 2 and data 3. So what we are going to do? We want to do inner join between these three tables. And these three tables I want to do inner join on the basis of ID variable, which is the common variable. And here you can see only 2 is there in all the three data sets, and that's what we see in our results here. But let's look into the code. And our code for the first join is very similar, wherein we say from 1A inner join to B on A.id equal to B.id. This is what we have seen before. So we are writing our first join wherein we are joining our A table to B table. And then we are writing inner join after this first join, and we are telling 3C, and then we are writing on A.id equal to C.id. So once this inner join we have written, we are writing a keyword inner join and then writing our third data set name, and then we are saying A.id is equal to C.id, and we are getting our result in here. Now let us also quickly look and try to understand how we are going to get our results. So when we are doing these joins which have more than one table, we need to understand that this takes place in a step-by-step fashion. What is that step-by-step fashion? When we are saying from 1A inner join 2B on A.id equal to B.id, that first does the join and gets you a result. Here 235 and 3000, there is a match. So we get this row into our result. And then once we get into that result, which we do not see, this one joins back to this one. So this is happening in 2 steps in the memory. So this is what you see in the result. So to sum it up, you write from 1A inner join 2B on A.id equal to B.id. The first join you write, and then you mention inner join 3C. So this is going to function as I have told to you earlier. Now what will happen if we do our left join? Again, the code is pretty similar, and here we are doing a left join all the way through, and only thing we are changing in the code is left join keyword instead of inner join, and this is what we get as a result but I would like to explain how this whole thing is going to function. Again, here you have from 1a left join 2b on a.id equal to b.id. So first 1, 2, 3, because this is our left table and it joins and we get all the information from left table 1, 2, 3, and we are going to get the information we need from the right table. This is what we get in the result first. That is, we get this piece of results first, and then we are again doing left join with the third table on a.id equal to c.id. And here again third table is the right table. So again we are going only to go get the result where it has a match, remaining all will be missing. So it is important to understand that this is our driver table, or we can say the important table we want all the results from. So we have kept this table the leftmost, and then we have done a left join. So we got these results, and in the results we have written a.id, a.age and b.salary. So salary only we get it when there is a match, and these results we get and they stay in the memory, and then another left join happens on a.id equal to c.id, and then you get this y here because you have written c.bonus underscore offered. Till now what we have seen here is very simple case scenario for our multiple table joins. We were either using inner join in both the ways and also the left join for both the times. So what I would want to show you, what happens if we swap one of this, and then we can understand it better. And also our on conditions were also very similar. We have taken one table as a driver table and then joined based on that. Now let's go a little bit more deeper. Here, for understanding this, what I have done is I have created a different data sets, and these data sets are known as test 1, test 2, test 3. And in the test 1, I have ID sal, in test 2, ID age, in test 3, ID and bank underscore amount. And here what I'm trying to do is, again, I'm trying to do a join on the base of ID. Here the data is little bit more so that we can understand the results better. So what are we going to do here? Here I'm trying to do an inner join followed by a left join. On test 1, inner join test 2 on a.id equal to b.id, left join test 3. But in the case of here, I am doing test 1, left join test 2 followed by an inner join. So what is happening in here? If you can see, the results are dramatically different. So let's try to understand this little bit more deeply. So first, when we do inner join between test 1 and test 2, what are we going to get? Here 1, 2, 3, 4 are IDs in my data set, but here I have 1, 3, 4. When I join on the basis of ID, I'm going to match 1, 3, 4 and 1, 3, 4. That's a part of my result. So my result will have ID 1, 3, 4 and respective sal values as 200, 400 and 400. And also I have age 35, 90, 29. As I said to you, these results are stored in memory and this happens in step-by-step fashion. So once you got this result, we are doing a left join. But now what are we trying to do is we are trying to map or we are trying to compare this ID to this ID. So I already have the results, and this ID 3 only has the match. So we get our result as follows. So this result we are able to understand, but let's try to do another one and try to understand what happens in here. Here I am doing test 1A left join test 2, which means I'm going to get 1, 2, 3, 4 and also the matching values of 1, 3, 4. So here my results have become little bit different in the first phase itself, where I have all the values from here. But what I am doing in the next step is I am doing an inner join with what the result I have got here, that is 1, 3, 4, and then I am doing on a.id equal to c.id. As if you see here with the inner join, 2 and 3 only match. So even though in my temporary result set I have 1, 2, 3, 4, once I have told inner join, it is going to have 2, 3 information only. So in the final output we have 2, 3 and we have 300, 400 because for 2 age is not there, so it will be missing. So if you see here, by just changing the order of join, our results do change. So it is very important to understand the order in which we do our joins and how we get the results. Obviously, whenever you have a missing value, that indicates that for that particular variable we do not had a match. Now that we have understood that order of join condition does definitely matter, now let's also look into something different. Now what I am changing in here is again very subtle change. In here I am writing a.id equal to b.id, wherein I am joining test1 left join test2 and then left join test3, again a.id equal to c.id. Here again my scenario is entirely same, except that here I am doing on b.id equal to c.id. So here again if you see, the results do change. And what is happening in here? In here again, whenever we do the left join between two tables, we get a temporary result data set which is stored in the memory, and in here it is again joining on a.id to c.id, that is our test3 tables. As it has match for 2 and 3, we have the values for 2 and 3. But whereas in the case of the second query, the query is pretty similar, so our results have same number of rows, but what we have differed is b.id equal to c.id, which means we are picking up the values from C only when it matches with B, that is only 3 matches, so only we have the value for 3. Here when we are telling C and A to match, here we have 2 and 3 matching, so we have the results for 2 and 3, whereas in the case we are saying B and C, we have the value only for 3 ID, that is this to this. So it is very important to understand what should be our joining tables, even though our conditions are same. To get the values in the variables in which we want to see, we need to do that. And one another subtle difference is the order in this particular ID for this particular code is little different. And really that does not matter because the results are what we have expected. Now let's look into little bit different topic about how to give additional conditions. Till now we were just talking about just one single on condition. And if you want to have an additional condition, all we need to do is we need to add an AND condition. And now our joining will happen both on the basis of these two conditions. First, when a.id equal to b.id, and also b.salary is 2000. Only this condition matches this only for id equal to 1, and I have in my select clause a.id, a.age and b.salary, so you can see the result as shown in here. If you have more conditions, you can add more ANDs. But here I want to tell one another thing. There is little bit difference between and where whenever we do a left join. I have made a video on that topic also. I will give the link for the same in the description below. Now let's move on to a different topic of cardinality, where we will talk about one-to-one, one-to-many and many-to-many joins. Till now, what we were mostly focused on about joining conditions and other things. We were not too much focused on the data itself. But now we are going to look into the data and we are going to talk about cardinality, that is one-to-one, one-to-many and many-to-many. Here, first we are going to talk about one-to-one join. One-to-one join is very simple and we have already spoken about that. One-to-one join means whenever you have the joining variable has only one value in first table and second table, as shown in here, it is known as one-to-one join. And here you can see the result whenever you have one-to-one join. For inner join, what we will have is 1 and 1 and the results related to that, 2 id2 and id2 here and the results pertaining to that. Whereas in the case of left join, we also have information from the left table where it does not have a matching ID in the right table. So basically the number of rows in the left join will be the number of rows which are there in the left table, and number of rows for inner join will be number of matching rows. Now let's look into one-to-many. In one-to-many, what I have done to show that concept is I've added many one IDs in here, and then we are doing the same inner join and we are doing the left join here. Whenever you have one-to-many, what will happen is this one will join with both ones, and now for this one in the result we have two ones, wherein we are going to see the result as 1 1 and also 2 where it has match. So whenever you have 1-to-1, you are going to multiply those values with 1 into how many manys you have here. Here you have 2 only. If you have 3, you will have 1 and 3 combinations. Here as we have 2, we see only 2 combinations. So which means one-to-many will have results in the form of 1 into many of the next table. So now for the left join, the results are also same, except that you have also the information from left table which does not have any matching in the right table. Now let's look into many-to-many, and many-to-many also follows the same pattern as we have shown in here. In many-to-many, what I have shown here is I have many same IDs here and many same IDs here. Now let us look this little bit closer. So this 125 will join with these two. This 130 will join with this two, which means whenever you have many to many, you have to kind of multiply the number of many to many records you have. When you have one to one, you multiply, it becomes one only, but you have one to many, you have one multiplied by many, whereas in the case of many to many, you have to multiply these two with these two, which means now we are going to have 4 rows. That is 125 with these two, 130 with these two, and you can see the result in here in our inner join. And we have to be always careful about many to many joins, especially when we have lots and lots of observations and lots of many to many joins. Then we are going to have a problem, because our data set or our resultant data set will have lot many rows. And in the case of left join, we will be additionally seeing the information from the left table which does not have match in the right table. Now that we have looked into many topics, now let us quickly look into some miscellaneous topics about which I will not go into a lot of detail, but I will quickly browse around those. The first one is, whenever we do a join, we can also do the aggregation in the same step. Most of the time when we were doing a join, what we were doing was we were joining the first table and the second table, and we were just bringing the variables by just doing from one inner join 2, and then we are saying on a.id equal to b.id, and we were bringing the variables. In this case, we were bringing id and salary from these two data sets, but we need not do just that, but we can also do a sum on this salary variable by just adding group by id. And in here I am saying group by a.id, and then I have select a.id, and then also I am doing sum on this salary. So this gives me results as follows. So not only you can bring the variables, but you can do the sum also in the same step in the inner join which we were doing. Now let me also talk about another topic which is not often very much discussed. What is that? In here, what happens when we have same variables in both data sets and we used them in the query and as well as in the create table? Now let's try to understand this through example. Here I have dataset 1 and dataset 2, and both have same variables id, age, and dataset 2 also have same variables. Now whenever we do a dot star and b dot star on our joining thing which we have discussed for a while, what will happen is we will see all the variables id, age from both the data sets. So this is simple and nothing to talk about. But another important thing to remember is what happens when we create the table. When we create table, it cannot keep the same variable name twice. What it does is whatever we mention first here, that is a dot star, those variables will be kept in the data set, and it will drop out the variables which are similar ones in the data set too. So if you see in the results, we have information from dataset 1 because the variables which are similar in dataset 2 will be dropped. So this is one important point to remember. That's all for this topic. If you have liked this topic, please give it a share, thumbs up, and subscribe. Thank you.